Hello everyone, and welcome to an 8-part series we're going to be doing on how to build PS4 applications using the OpenOrbis PS4 toolchain. And this toolchain just dropped at the same time as these videos are going out. So through these 8 videos, we're going to first be going through an overview of the toolchain and what's included in it, as well as how to install it on Windows and Linux, and that's what this video is about. But in sequential videos, we're going to be going through how to create projects, how to build like a simple 2D graphics drawing just to get you familiar with the toolchain, how to build an application that does that, and then how to finally package that and run it on the PS4 itself. And then we're going to be going through some of the debugging tools that are available to you to help you with debugging and building your own tools and stuff like that. So let's just jump right into this video, and then we'll get into the other ones later. So this video is going to be doing an overview of the toolchain. So what's included is obviously the header files and stuff like that necessary to start building applications, but there's some other things in there too that some people might find helpful, so we're going to go through all of that. After that, we're going to be going through how to install LLVM, because this toolchain leverages LLVM, so we're going to be going through how to install that on both Windows and Linux. And then finally, we're going to be going through setting up the toolchain itself on Windows, and we're going to be doing that 2 different ways. First way, we're going to use an installer. For people who don't want to use an installer, we are also going to show you how to do it manually. And then on Linux, we're going to show you how to do it just through the command line. So, without further ado, let's get right into the overview of the toolchain. Okay, so when you download the toolchain or look at it in the repo, you're going to get a folder that looks something like this. So we're going to be going through each directory bit by bit. We're not going to be going too in depth in everything that's in those directories, but we're going to be going through them and just giving like a broad overview of some of the stuff you can find in there. So up first is bin. As you can probably guess, this includes all the binary files. So first we have data. This includes materials that we're going to be using for creating the PS4 package file. This we're not going to be worrying about until a little bit later in this series when we're actually building a package and running it on the PS4. So we'll get into these a little bit more in that video. Linux includes all the executables for if you're using the toolchain on Linux, and it's also there in the Windows installation just in case you want to use them for WSL or something like that. Now this directory isn't complete. There's going to be a lot more binaries in here than there is right now, but this is just for the tutorial that we're recording so it can drop with the toolchain. But we haven't finalized continuous integration yet, so some of these directories are going to look a little bit different when you actually download them. But a few tools in here that are critical to the toolchain's operation is create eboot and create lib. These are used for creating games and libraries respectively. These are going to be called by pretty much every build script from any projects you make and the samples, anything like that. They're going to call these to make the final elf that is compatible with the PS4, or I should say self. The make fself is here as well for convenience, but make fself is typically done through create eboot. Readelf is a replacement for the readelf you're probably familiar with. If you've done like Linux development, you've looked at elfs, you've probably used the readelf tool. This one is a replacement that works with PS4 elfs, because PS4 elfs actually have custom dynamic linking. So this has all the specialized PS4 stuff that isn't in normal elfs. So like I said, there's going to be more binaries in here, but right now these are the critical 4, and that's why they're here right now. For Windows, looks much the same with a few additions. We also have the Assistant Suite. So the Assistant Suite is going to include a kernel log viewer, mirror launcher, as well as a debugger, which isn't in here right now, and all the DLLs necessary for the operation of all of those. And then we also have the ones we had in Linux, where we have create eboot, we have create lib, and we have readelf. So bin is pretty much done. Like I said, those directories are a little bit different from what they're going to be because there's some stuff missing in there. Once we get CI set up, those are going to look a lot more complete. So docs, as you can probably guess, it has documentation, and we have 2 versions of documentation. We have Markdown and PDF. This is mainly for people who want to open up PDFs and get like a more pretty view, I guess, of it. Markdown is there for people who just want to be able to open it up in a text editor quickly and not have to, decode it. So This is another directory where we don't have all the documentation written and properly set up in there yet, but in here what you're going to be able to find is the OL specification, which is in there now. There's also going to be a local mirror of the wiki in there, which is going to include a lot of like useful function listings and stuff like that, and there's going to be some other documentation in there as well. And the PDF and the Markdown ones are going to include the same stuff, basically just in different formats. The extra folder includes things that aren't really necessary for the operation of the toolchain. Well, actually, these two kind of are, but they're mainly there for like extra convenience things. So let me get into some of the stuff that's in here. First, we have the install NSI script, and this is actually used for scripting the installer for Windows, which we're actually going to be getting into in this video. And these two files are the Visual Studio project templates, which we're going to be getting into in the next video when we're going to be creating projects. And this allows us to create our own project types in Visual Studio. So that way you can create a new project and create a PS4 project right from there and not have to do any of the setup. It's very, very nice. We're going to be getting into that in the next video. But anything like that's miscellaneous that doesn't really fit into the other directories is going to end up in this folder. So this folder is probably going to grow as time goes on. Include, this is going to be the bulk of where all of your storage space is going to go, because this basically includes a full set of libc headers that are customized actually because there's a few changes that Sony made to libc. We have the libc headers in there as well, and as well as that we also have Orbis headers. So this is for all the PS4 specific libraries. Now, these headers just include the function definitions and the reverse types. This is one area where if you want to contribute to the open source toolchain, help would be appreciated because some of these are not complete, especially the ones that aren't really used as much. So if you want to jump in and try to contribute, you can do some reversing and fill in these headers. It would be greatly appreciated. So yeah, these basically include the types and function prototypes for PS4 library functions. Speaking of library functions, we have lib up next. This includes dynamic libraries and some static just object files for building against and compiling against with the toolchain. Now, one thing I will note, you're seeing SO files here, shared objects, and usually in dynamic libraries, these files are going to contain implementation of the functions. But because we want to be legally safe, we cannot redistribute any Sony libraries with the toolchain, so these are actually shells. These libraries do not contain the actual implementation of the libraries, but they're needed for create eboot, which is that tool I showed off earlier. So they're there, they're necessary, but they're not really going to contain too much interesting stuff in terms of like reversing or anything like that. So they're there, but they're shells basically. Samples. This directory is probably going to be the most interesting to you as you're, jumping in and getting familiar with the toolchain, because this is going to include a bunch of sample projects that are really good for reference and just for, if you want to build something and see how it works. So we have like an audio sample, we have one that draws text to the screen, we have one that does like networking and draws a PNG to the screen. So we have a bunch of different samples. This is another directory where there's probably going to be more added over time, and you're absolutely free to contribute any samples you would like to, because more samples are always welcome. So this is going to be something you're going to want to probably check out. And just to get into one, here's the font one, for example. It's going to include a screenshot of actually pulled from the PS4 of what it looks like. So there's one, for example. And it's going to include the Visual Studio project as well as a makefile for if you want to build it on Linux. Scripts. So this folder doesn't really contain anything super important. This is mostly just here for completion. Most of these scripts are just scripts that I used for when I was reverse engineering the format of PS4 ELFs. They're probably not really, you're not going to use them really, but they're there for anybody who's interested. There's also Flatz's make fself script, which, again, is there in the interest of people who want to check it out, and it's there because Flatz did a lot of the reversing on selfs, but that's also handled by create eboot, so you're probably not going to want to run that because create eboot handles that anyway. And then there's the auto build script, which we're still working on for automatically building. Okay, so the last directory we have up is source. This directory contains the source code for all of the tools you've seen in the toolchain, as well as Maxton's create package tool, which will allow us to create packages, which we're going to be using later for running stuff on the PS4. So in here we have like the C runtime stub, we have the template files for Visual Studio, and we have the assistant tool suite, create eboot. There's Maxton's tool, Miralib, which we're actually going to be getting into on the tail end of the series. So there's basically a bunch of tools in here that you can check out the source for, get hacking on, and or just check out if you're curious. So that's all the directories. The files here that are left are just like the license file. The linker script is kind of important. I will bring it up just for anybody that's interested. This is the linker script. Now, you're probably not really going to want to touch this, but this is important for actually building the applications. This tells it how to structure the final elf. So if you're interested in that, you can check that out, but you're not going to want to touch that really. That's there for the scripts and stuff to use. And then we have the README, which I'll pull up. Basically, it includes some of the information we're talking about in this video, but just in written form. So it has, the overview, the documentation, setup instructions, credits and contribution and stuff like that. So that's what you're going to see if you open up the repo on GitHub, for example, is this README. And that pretty much concludes everything. So now that we've went through everything that's in the toolchain, we're going to get into actually setting up the toolchain. So first, we're going to be doing that on Windows with the installer. Before we install the toolchain, we're going to need to install LLVM because the toolchain leverages LLVM for doing things like linking and compiling using Clang. So for Windows, we can just search up LLVM Windows installer, and that will take us to the official LLVM.org website and the download for the installer for installing it on Windows. So we can just use the pre-built binaries. We don't need to build LLVM ourselves because if you don't have a powerful computer, that's probably not going to work out too well for you. So go down here to pre-built binaries, hit Windows 64-bit. That will download an installer, and then you just simply run it. So I already have LLVM installed, so I'm not going to go through the install dialog because I don't really want to uninstall it and reinstall it. But essentially just follow the dialog until you have LLVM installed. You may have to do a reboot, and then we're good to go on the toolchain. Installing through the Windows installer is remarkably easy because we use the nullsoft install script system. So you can just go ahead and run the installer executable. And when you open it up, you're just going to specify the destination folder that you want to install the toolchain to. I'm going to specify a test folder. So I just set it to install to PS4 toolchain on my D drive, and then you just hit install. Then you just wait for the installer to finish, and it's going to do everything for you. It's going to extract all the toolchain files in there, and it's going to set up the environment variable, which all the scripts are going to be using. Now that it's finished, we can just go to the directory that we specified for the installation, and we can see all the files we were talking about earlier, and the environment variable's been set up. Now you can just open up a sample project or create a project, which we're going to be getting into in the next video, and just get started right away. Installer makes it really easy. Now we're going to be getting into how to do it without an installer if you want to do it manually. So now we're going to get into how to install the toolchain on Windows manually for people who don't want to use the installer. So for this, I've pulled up the GitHub repo. Now this is actually not the repo that you will be seeing because right now the toolchain is private. This is the dev repo, which is on my personal account. But when this drops, this is going to be on the OpenOrbis GitHub. So you can just go to that page, which will be in the description below, and you can clone the repo or use a release because a release will be created when it goes public. So you can download the zip, do a local clone, and then when you do that, you can just open up the zip and extract this anywhere you want on your system, just like the installer would do. So once you've done that, all you need to do is set up an environment variable. So I'm going to go ahead and extract this really quick just for the video. So I've wiped that PS4 toolchain directory that the installer wrote to earlier, and we're just going to go ahead and extract the files to this same directory here. Now that all the files have been extracted, the only step left is to set up the environment variable that's needed by all the scripts for knowing where the toolchain is actually installed. So to do that, we're just going to go to Windows and we're going to edit environment variables for our account. And then when we get there, we're just going to create a new user variable and we're going to call it OOPS4 toolchain. And we're going to set the value to a directory and hit OK and hit OK again. And then there we go. That's all we need to do to set up the toolchain. So it's not hard to do manually, but it is a little bit easier to do it through the installer. So I am now going to be showing you guys how to install the toolchain on Linux. So for this, I've booted up an Ubuntu VM. So before we can get to installing the actual toolchain, just like Windows, we have to install LLVM first because it's built on top of it. So to do this, we're just going to do sudo apt-get install LLVM, sudo apt-get install clang, and sudo apt-get install LLD. So I already have all of these packages, so you can see it's saying it's already been installed. But for you, you might not have these. If you do, cool. But you're going to want all three of these packages, and that's going to give you all the binaries you need and that the toolchain needs to be able to do its job. So now that we have the dependencies set up, we can get to the actual toolchain. So for getting the toolchain files, you can go about it one of two ways. You can either get it through a release zip like I did, or you can git clone the repo. I would recommend a release zip just because those are stable releases, whereas if you clone it from the repo, depending on what commits are on there, they haven't made it to release, so it's not necessarily stable. Okay, so first set up a directory where you want the toolchain files to go. I've already created one in home called PS4 toolchain, and then you're just going to simply extract the zip files there, and that's going to be really quick. It's only going to take a second here. And then once that's done, we just need to set up the environment variable, okay? Just like Windows. So to do this, we're going to edit the .bashrc file, which is in your home directory. So we're going to use nano to do this. So just hit nano /bashrc. And for those of you that don't know, this file is basically a set of commands that's executed by bash every time you open up a new shell. So it's very convenient. We're going to add our own command in here, which is going to export the environment variable. So at the bottom of the file, we're going to do export OO-PS4 toolchain, same name as the environment variable on Windows. And then we're just going to specify the directory that we put the toolchain files in. So PS4 toolchain. All right, just like that. And then for this terminal, since we've already had it running, we're just going to source that bashrc file. And from now on, even after reboot, every time you open up a terminal, that environment variable is going to be exported for you already. So you just have to do that once. So if we go ahead and echo that environment variable we just wrote, we can see it prints the path to where we installed the toolchain. Awesome. So there is one additional step on Linux that we didn't have to do on Windows, and that's because of the way permissions are set up on Linux, or at least on Ubuntu. By default, files that you extract here are not going to be executable, which is a problem for the binary files. So we're going to fix that really quick. So using that environment variable, we're going to go into the toolchain and we're going to go into bin Linux. Okay, so this is all of our files right here. And then we're just going to make these files executable. So we're going to do chmod +x create eboot. And we're going to replicate that for create lib and readelf. Now, we can do make fself as well, just for completeness, but this file isn't really used, but we'll do it anyway because it's there. Okay, so this is actually, I'm going to try to work on a script that actually does this, because running these commands can be a little bit annoying. So at the time of release, the extra folder is actually going to create a script that you can just run that'll do this for you, and that way you won't have to do that. So now that everything is set up, we can just demonstrate that the toolchain works by just compiling the hello world sample. So we'll go into samples, hello world, and then we're just going to run the make file by running make. And as you can see, if we do an ls-l, we will see that the eboot.bin file has been created right here. So that's all there is to setting up the toolchain. It's not too difficult. For Linux, it's a little bit more work, but it's something that you're just going to have to do once, and then it's set up, and you can just, go off and do whatever you want to do. So that's all there is to installing the toolchain. In the next video, we're going to be getting into actually setting up projects so we can start coding and writing applications that we're going to eventually run. And I'll see you guys in part 2.